Okay, we'll make a start. So welcome to this webinar about using automated condition monitoring and smart sensors for asset performance management. The webinar has been organised by the Institution of Mechanical Engineers Process Industries Division. My name's Richard Hellebrand. I was a maintenance manager in the process industries for around 30 years, so I'm looking forward to hearing about developments from our expert speakers today. Now, before we get started properly, just a little bit of housekeeping. The event is being recorded. It will be available on YouTube. To allow for a smoother presentation, we've turned off attendees' mics and cameras. If you're a registered delegate and you attend most of this webinar, you'll get a CPD certificate. If you've got questions, please pop them in the chat or in the Q&A. I'll keep an eye on those while our speakers are talking, answer some of them as I go along, and others will save up and we'll have the panel discussion at the end. The speakers will make the slides available as a PDF as well to people who get the CPD certificates. I will also, if I see any AI chatbots in, I will make them exit the meeting. People only, please. We have got an equity, diversity and inclusion policy at IMechE because we believe engineering's for everyone. So our vision is to foster inclusive culture where all people feel valued. We're committed to embedding inclusion in every aspect of the institution, and you can see some more details there. And we also celebrate diversity amongst all our members, employees and the wider engineering community. So everyone's welcome. Our speakers today, Sergey Putsunev, Sheriff Essa, and me. Let them talk about themselves a little bit more, but you should see the basic details on the setup for this webinar. And before I just hand over to TUV Rhineland, I would just want to do 2 or 3 slides of my own to sort of put some context on this. I am conscious that it's a TUV Rhineland presentation. There are plenty of other people around who are involved with condition monitoring, asset performance management as well. So perhaps a little bit of background. So APM, the whole reason for it really is to try and extend the bathtub curve to the right. Our typical process plants, factories have a life. All the assets within them have a life. Job of reliability people and maintenance people is to make sure they stay safe and perform, and just push that to the right to get as much life as we can out of those in a safe way. And to do that, if you look at a typical maintenance strategy, unfortunately, many plants and processes are still on the left. They're still under breakdown maintenance. But if you introduce preventative maintenance, you can start to move the overall equipment effectiveness a little bit better. Plan maintenance, schedule replacements, turnarounds, shutdowns. But if you really want to move your OEE towards world class, then condition-based monitoring is a very significant tool to use. We really want to get to this world-class OEE up around the 90%-ish mark. It's very hard to do that. I've got some background in this, but I'm very interested to hear what TUV Rhineland have got about APM, because really when I was practicing, it wasn't APM, it was just asset integrity management, and the new technologies were just that. They were just coming in as new. I think everyone probably on the call knows that you've got easily availability of infrared cameras, oil sampling from basic taking a sample, sending it off for analysis, to actual remote full online stuff. And plenty of other suppliers are around. And the same with vibration monitors, which are mainly on rotating equipment. Lots and lots of suppliers of these, from cheap and cheerful up to very sophisticated, networked, ATEX approved designs. So that's it from me. I'll just now hand over to Sheriff, please, if you can take over the screen and right from your side.
Hi, yep. I'm just in the process of loading my screen, so everyone should see it in the next second or two. Just confirm when you do, and then I'll get started.
Yep, you're clear.
Perfect. Go full screen. So good morning, good afternoon, or good evening, depending on where you are. So my name is Sharif Essa. I'm a project manager within TUV, and I have been for the last 11 years. And I specialize in asset performance management solutions and deploying them for customer organizations. Just to give you a brief agenda of what me and my colleague Sergey are going to talk about. So we're going to talk about asset performance management with a particular focus on condition monitoring. I'll be mainly focusing on rotating equipment. Sergey will be focusing on static equipment. We'll take you through some case studies and we'll leave some space for some questions and answers towards the end. So before I get into the whole webinar, and for those of you who are keen-eyed, you will have noticed that my first slide is labeled Asset Performance Management, even though the title is Condition Monitoring for this webinar. So I wanted to get into a bit of a clarification frame where we try to distinguish between the two. So asset performance management, it's been thrown around a lot and it's got a lot of misconceptions around it. And it's commonly conflated or confused with condition monitoring. So asset performance management is a holistic framework for how you manage your assets. So this includes your people, your process, and your technology. Whereas condition monitoring focuses on the condition of your asset. That's the distinction I'd like to sort of keep clear, and I'd like you all to bear it in your mind. There's a lot of common misconceptions around asset performance management, and the biggest one that I've come across that it is just the technology. People think APM is just technology focused and that's all there is. But just to sort of demystify that, there is a lot of man hours or people and processes involved in the management of assets, and they're equally as vital as the technology that you employ. And so why do people gravitate towards APM or sort of any technology out there on the market? And at the moment, as I'm sure most of you will know, there's a lot of challenges in the market, whether they're political or site specific or equipment specific. But ultimately, we're all in a market that requires incredibly reliable assets with very little investments that's willing to go into a lot of these assets. So as engineers, our role is to get the most out of our assets with as little investment as we possibly can put into these assets. It's not an ideal world, but it's the world we live in. And so why does APM fit in? And APM fits in because it promises a lot. It promises to minimize your spending on OPEX. It promises to improve your uptime. And if you believe the ARC survey that was conducted, most operators can eliminate between 2 to 5% of their unplanned downtime. So obviously the apple is there, it's big, and a lot of you will want it. But unfortunately, the reality of APM is that it doesn't often meet expectations. And that's largely because, and at least in my experience anyway, is that the people and processes aren't generally aligned with the technology. So there's a lot of focus on the technology, but people generally leave the people and process out of it. But ultimately, software is just a software. It's a way that provides you with more information or more insight, but it's your people and process that will drive the value, and that's what will actually make the difference. So this is the TUV approach, and this is what we sort of try to bring in as part of our organization. And I'm sure as mechanical engineers, a lot of you will have seen numerous bathtub curves. But essentially what we believe in our organization, that if you bring the people and process together, you can reduce how much you spend on technology and also improve the effectiveness of that technology that you deploy. So bringing you somewhere near the middle. And that's the optimum place where you want to be, where you're spending just about the right amount of money on the technology to get the real value out of it, without the over excessive costs with some of the technology out there. moving on to the next slide. So TUV's got an approach for both static and rotating equipment. And for this sort of part of the presentation, as I mentioned at the start, I'll be largely focusing on the rotating equipment with the sensors on board. If you go to market, as Richard mentioned earlier, there's thousands and thousands of sensors out there. And a lot of them will promise you the world, as sort of sales will commonly push out. But it's down to you guys to sort of make the distinction and prioritize where these sensors make sense. The best sensor for you, you should be able to determine it from your detailed risk assessments, whether that you be doing RBIs or IMechEs, failure modes and effects, failure mode effects and criticality analysis. And these detailed risk assessments will tell you where you should be putting sensors, what degradation or failure mechanisms you're looking for. And as a result, if you're monitoring these things, you'll be able to identify the failure long before it occurs. And it'll give you that value that you're after. So I'm not going to go into detail of all the sensors out there. You can use them in numerous ways, but feel free to do sort of your own research on them. But as part of today's presentation, I'll be focusing on ABB sensor. But just to sort of reinforce Richard's message, there is a lot of other sensors out there. ABB sensor is one I'm very familiar with. I can talk about it for days, but there's other ones out there. So as I mentioned before, although I am focusing on the technology, it is important to remember that the people and process bits is what will drive a lot of the value out of this technology. The technology is just one attribute of what you're going to get out. So on screen, I've got the ABB sensor. It's about the size of your hand. It's relatively small. It's got a lot of features to it, but one of the two key features that I'd like to bring out is that it's got a 15-year battery and it's jet proof. So you can put it in most environments and it will survive fine. It's also ATEX rated for those who are concerned. What this sensor does is it measures some key metrics from wherever you mount it, and the sort of the key ones, I've listed them on the screen. And then using the measurements that it's taken out, it will calculate some other metrics. And all of them are sort of listed down here. So you've got the vibration side of it, but it'll also calculate misalignment or cavitation, depending on the type of equipment that you mount it on. And all this data is sort of pushed into this neat platform, and it'll give you visibility of the data, but it's down to you guys as the engineers to make the decision out of this data. So sort of going through the first example, and this is a sensor, and I'm displaying a vibration period of 60 days. And the sensor has been in operation in 60 days. And for those of you who will have already spotted it, in some cases it's gone above the threshold. In other cases it hasn't. But when you first mount these sensors, they don't just work immediately. They take a little bit of time to sort of gather enough data, and you set the right benchmark. It doesn't happen overnight. But once you've got the right benchmark, the engineers will sort of play with it or tweak the sensor settings to sort of redefine what is the upper threshold and what is the medium threshold and what is the lower threshold in terms of where this asset should be. And this is where the reliability engineers get very keen and like to look at this kind of data. So sort of moving on to the next slide, what is the beauty of having a sort of long trends of vibration? So in this case, I've got 45 days. And as you can see, over time, this particular asset or this motor in question was getting worse and worse. The site spotted it and decided to carry out some remediation work and address the issue that the sensors were picking up. And as you can see where the big blue arrow is, work has happened, or the guys have done some work, the system's carried back online. And one of the best things, or at least one of the most rewarding factors from my perspective, is that you can see once the bearing was changed, or sorry, the issue was addressed, you could see the systems operating again in the safe threshold. So, the work was done, and it was also done to a point where the asset is safe. So there's less risk, less residual risk in this particular asset. And this is always sort of good reaffirmation, at least from an operator's perspective, to see that, yes, this asset is the work that's been done on it has delivered the value that you anticipated to deliver. Looking at another example, so this is a pump and motor. So the top side is the pump, the bottom side is the motor. Sorry, the other way around. The bottom is the pump, top is the motor. And they're both connected to each other, and at some point misalignment was introduced, intentionally or unintentionally. But the sensors picked it up, flagged the warning to the operators or the engineer who was monitoring the application. And again, the site was able to address it. And again, after the work, you could see that the system has gone into the sort of safest thresholds or back to normal operating conditions. So again, for a little bit of sort of forward planning, you can address issues long before they turn into serious ones. Last but not least on my slides for today is the sort of the overview or the historical look of data. So these sensors, or at least the ABB sensors, as I mentioned, you can mount them on a system for 15 years. So that means in about 5, 10, 15 years time, you'll have a good historical overview of data. And this sort of aggregated data log or data view that you get from gathering this data will enable you to feed into other asset classes. So if you've got motor A and motor B, if they're not behaving similarly or there's something different about them, then you can start to pick these trends earlier and address them and introduce them as part of your people and process changes that you're trying to sort of factor in and build up. But ultimately, the key message I'm trying to give is technology is just one attribute of your maintenance reliability. It's the people and processes and how they channel into this technology and how they adopt the technology that'll give you the value. Now, I'm going to pass on to my colleague, Sergey, who will talk about static equipment. Sergey?
Yes, I think I'm unmuted now. Thank you, Sheriff, for this informative insights into condition monitoring of rotating equipment. Obviously, in addition to rotating equipment, the asset performance management equally applies to condition monitoring of the static equipment as well. And this is my area of expertise. My name is Sergey Putintsev. I'm business field manager within TV Ireland UK, responsible for industrial inspections, material testing, and non-destructive testing. And today, I will look at the automated condition monitoring solutions for corrosion monitoring, which is the most common damage mechanism at the chemical and petrochemical facilities. Obviously, there are other damage mechanisms, for example, creep and creep fatigue, especially in the power industry. And there are very interesting automated centers developed for those specific applications. So if anyone is interested, please contact me and I will provide further information. But today, let's dive into corrosion monitoring. Let me see if yeah. A typical situation at a process facility is when written scheme of examinations are prepared by independent competence person, and then the inspection company would perform the required inspection as per written scheme of examination. So NET reports are submitted to the maintenance and process engineers who will look at them, and undoubtedly they will have a number of questions. And these questions will be, what do we consider? Do we consider general corrosion or localized corrosion? And in most cases, we are talking about localized corrosion. Is the corrosion rate linear or non-linear? And again, in most cases, it is not linear. And do we have detailed information how the assets operated? The answer is yes, but it's not commonly consolidated with the inspection data. So this raise a number of challenges for maintenance managers and process engineers who would ask themselves, if I knew the day-to-day localized corrosion rate, and if I knew which changes in operating conditions would impact on this rate, will then I can run my assets more efficiently and manage them better and extend their life? And of course, the answer is yes. So good, let's go and measure this corrosion rate in order to answer those questions. And here, let's compare the data that we can collect through manual inspections. And when we are talking about corrosion measurements, we basically take the wall thickness measurements. So we can do it manually through, let's say, manual UT, and we can compare it also to automated monitoring. And this is example coming from one of our partners in US, where a certain asset was monitored on a continuous basis, and the inspections were taken at a regular interval every second month, and they were plotted into the graph. Obviously, as with any manual NDT, there could be some deviations, and you always be asking what's that reason. Is it exactly the same location where the measurement was taken? Was there any impact of the temperature, or maybe there was a wrong calibration, or could be just a human error? That always comes with the manual measurements. But more importantly, if we take these measurements for granted, then there is a question, okay, so how could I calculate my corrosion rate? Am I crossing these dots this way or different way? So which corrosion rate I'm taking? Is it the red line, which is steep growth of corrosion, or much more stable blue line? So what happened on this specific case, actually in parallel with manual NDT, there were sensors being installed at the same time, which were taking the measurements every hour, because that's a benefit of automated system. You can program it and take the measurements at any intervals that you wish. And then we can plot the data of compare automated measurements with the manual ones. And here you can see that if you, first of all, the data is much more accurate because it is collected exactly from the same location, exactly at the same condition. But also you can then analyze the trend and compare it to any changes on the processes. And what happened here is that there were specifically two changes in the process happened, which immediately impacted on the corrosion rate. And that was picked up by the sensors because they were taking very frequent measurements quite accurately. And obviously that wouldn't be possible just by looking at the manual UT measurements that commonly we have in our facilities. So the advantages of sensor technology is that the corrosion is very rare, linear, and it's continuous, also not all the time. There could be some unexpected and irregular intervals, which something prompt corrosion to accelerate and something that inhibit and depress the growth. And for that reason, the periodic inspections with very long intervals between the inspection points, not able to raise the integrity safety alarm in time. So automated sensor technology, based on a very robust UT. It's basically UT technology, but with a very high repeatability and accuracy. And it's also combined with wireless connectivity, because the sensors you can control and obtain the data from those sensors on a wireless basis. And that provides quite a lot of advantages, not just for the maintenance people, but also for process corrosion engineers. Just very quickly how it works. Richard said that correctly said that there are a number of sensors. I think you have much higher variety of sensors for the rotating equipment, much less variety for the corrosion monitoring. Nevertheless, there are a few leading brands that exist in the market. Sensors themselves are attached to the surface. They can go through coatings. Generally, the installation will have to be removed, but then it can be put back, and the sensors are attached to the surface and remain there. They can operate at low temperatures as well as quite high temperatures. They all similar to rotating equipment, powered by batteries, which lasts quite long nowadays compared to the early days. And the data is transmitted through wirelessly. That's the kind of most recommended part. However, you can also connect it through the wire and make a wired connection to the either directly to your system or to the gateway. And I think where actually we see more difference between the sensors is not the sensor themselves, but how they're connected, and whether they're using LoRaWAN system or whether they're using wireless HART, because there are pros and cons of both this connection system. I mentioned already about advantages and benefits of automated monitoring for the corrosion, and commonly people look at it from a benefit from cost savings. That's for the maintenance and integrity, and it's absolutely correct, especially if we consider placing those sensors at areas which is difficult to access, or where the cost of removing insulation or recoating, or actually even getting inside of the getting closer to the object will could be more costly than actually perform the inspection. So obviously then the automated sensors play much better role in it. However, what I would like to emphasize, and we see this more and more, is the benefit for the process engineers, because then they immediately can have access to live corrosion data over a period of time, and they can correlate this to any changes in the process. And that is extremely valuable information, because it allows them to optimize the production rates based on tweaking the certain process characteristics on their plants. Here, just a few examples from one of our partners, Edify. So they have a different type of sensors. As I said, there are at least 3 or 4 international brands that doing UT sensor technologies, and they can be connected wiredly or through wireless, and it could cover just a specific point, like on the microbeams. It could take array of points through smart, or it could have as a whole area, certain zone that can cover straight away. Obviously, in ideal world, and maybe that's what will come in the future with some of the new developments that we are seeing, the whole asset surface, or at least critical areas, would be covered with the sensors. That would be, I think, the future. But at the moment, that's not the case, because let's admit it, those sensors are expensive still. The prices are going down as the technology develops, but nevertheless, at the moment, it will not be economical to cover the whole asset with those sensors, especially once again, UT-based, they're just taking the point measurements. They only measure wall thickness where you fix them. So it would be quite costly to cover the whole area. So what we see that if you look at the total assets, first of all, we eliminate rotating equipment, so we just focus on static equipment, piping, vessels, tanks, support structures. Then through your asset integrity management RBI approach, you select your key critical equipment. Then within those critical equipment, we would recommend to look first of all for high internal corrosion rate potential, where the corrosion rate expected to be the highest. And then out of that selected equipment, you can also compare whether it's practical to do it manually or more efficient to do it through sensors. So you selected, at least in the beginning, your corrosion monitoring locations where you have difficulty to, for example, access it. It could be high level pipelines. It could be areas that require build of scaffold. It could be buried piping, confined areas, and so on. That would be most logical areas to put the sensors from maintenance point of view. But again, from process engineers, if you want to monitor the corrosion rate and impact of the process changes, then you fix those sensors in your critical equipment. Just give me a second. Just a few examples coming again shared with us with our partner, because it's good to illustrate the benefit and not just cost savings, but the overall benefits that sensors add to the company. This is one of the vessels which was inspected 2 times a year, obviously inspected manually with the cost of inspection, and regardless to inspections, there were at least one unplanned shutdown happening every couple of years. So the client decided to install actually quite small, just 4 different sensors. So it's not a big investment in terms of CapEx. And the corrosion rate was compared with the process changes, and then it was quite clear, and I'll show you the next slide, where the corrosion rate just dropping, and that was when the new dosing was introduced to the plant. And understanding this process, understanding what triggers the corrosion, brought very huge savings to the client, because first of all, there was a savings on the shutdown time and unplanned shutdowns which are happening, and also the extension life of that column. And this is what you will see is that until there was a process change, the corrosion rate was pretty stable. And that was clearly shown through the measurements. But when there was a process change, then immediately you can see impact in the corrosion rate. Another example, similar with the sulfur recovery unit, and here, because of the criticality of this assets, inspection was happening monthly, so it was relatively expensive exercise to do it. But again, but nevertheless, there was unplanned shutdowns to repair the leaks, and for that, of course, cost quite a lot of trouble for the management, for the operator. The sensors, this time it was much bigger investment, because you need to cover much bigger areas. So 12 sensors were installed, and it was able to see when again the corrosion rates were affected and what process change impacted on that difference in the corrosion rate. And this is resulted in a quite significant savings for the client to optimize the process. Once again, there's you can see the periods when the corrosion rates were maybe not good, but at least it was stable, and therefore you can predict it, you can use it for your RBI calculations, but then the change in the process made a step change in the corrosion rate. You as just a small example, these tubes were actually, they were not considered to be critical, therefore there were no specific inspection requirements or regime by the clients, therefore there was no cost of inspection, but at the same time there was regular leaks and failures of those tubes. So by installing the sensors, again, relatively small investment, it was identified what causes this spike in the corrosion, and actually it was caused by the cleanings. So the cleanings also then changed from 5 times a year just to 2 times a year, and as a result, the life of the tube increased significantly. And one last one on a small diameter piping. Again, client was performing manual inspection and NDT, but despite having the data, the corrosion rate appeared to be very unstable. So it was difficult to understand what's happening with the process. And by installing the sensors, again, it was quite a large investment because you need to collect a lot of data from different points. The finding was that the corrosion rate was clearly dependent on the changes of the temperature, and that allowed the operator to optimize the process and therefore extend life of the asset and minimize the repairs. So if I give a short summary and conclusion, I will put it for both rotating equipment and for static equipment all together. As Sheriff said earlier, automated monitoring system provides you with information. That's the best value that they do, and it's quite robust and quite versatile. And now with the development of technology, the variety of the sensors and capability of the sensors improving year on year. However, the question is, what do we do with this information? So obviously it supports a lot in prioritization of activities, and this is where the engineers, and maybe, look, I would assume that in the nearest future we will see also a lot of impact and advantages of artificial intelligence playing in this specific area to help you analyze the data correlated with the processes and help you to develop the maintenance strategies, best utilization of your assets, and also, in fact, it will trigger the culture change at operators, how we manage our assets. So it gives you a lot of insights to the asset, but it depends on people. It depends on our knowledge, and hopefully it will be enhanced shortly with some AI tools that we're already seeing in some areas, including our company. Our approach to condition monitoring First of all, we're proud to be experts in the field of overall maintenance and reliability. Not just relates to condition monitoring, but this is area of expertise of TUI Rhineland with very long history working with the various assets. We have very deep understanding of damage mechanisms and how to assess them, and that allow us to work with the clients and advise them on a strategy how to implement or improve asset performance management on their sides. And when it comes to specifically condition monitoring, we would advise, okay, what strategy is the best, which sensors are better suited, where to install them. We act independent. We do not manufacture our own sensors for at least for corrosion monitoring and also for rotating equipment. We have some specialist areas, but not these ones, and we don't have any kind of biased approach to the technologies available on the market. It's more to provide clients with advice and recommendations, and then obviously afterwards we can assist with procurement of those sensors or leasing from ourselves, and ultimately installing them and helping clients to analyze the data, interpret it, and decide on the next cycle, okay, how to improve your performance management. I think that's as the main part. I will not spend more than 1 minute. So just why we are talking about. So we as a TUI Rhineland been in this industry for over 150 years, starting actually with pressure equipment, so corrosion, creep fatigues, all the damage mechanisms are very, very familiar, and this is in our blood going forwards. I will not bother you. We have different expertise within our organization, over 20,000 people working here. But what I want to, as my last slide, to emphasize that within the area of asset performance management and condition monitoring, we have a dedicated teams here in UK working on integrity management for chemical, petrochemical, power industry, dealing with the aging assets, where we provide clients with the full spectrum of IPM and asset integrity management services. And we also have team working in the digital software and artificial intelligence, and we combining those two knowledges together in order to stay ahead of the market on the technology development, but also advise our clients regarding the best practices and best approaches to improving the performance management. And that's it. Our contact details here. So if anyone is interested to get in touch afterwards, as Richard mentioned, the presentation will be shared and you will have our contact details.
Brilliant. So again, perhaps leave that slide up while we're having our Q&A, because then people can note down contact details if they want. And I'll have a few more slides to finish off in a minute, but there's actually been quite a lot of questions. Sharif, perhaps you can also turn your camera on. As I say, quite a lot of questions. So gird your loins for this. So
we like questions.
First question from Alfred Zorabian. What's the difference between modern condition monitoring and condition monitoring? What's new? How do we move from condition monitoring to modern condition monitoring for the old rotating equipment?
So for rotating equipment, and I think, again, there's a lot of meaning behind the terminology of modern condition monitoring versus condition monitoring. In my head, or at least my understanding, is they all roughly mean the same things. But when people talk about modern condition monitoring, they typically mean the battery-powered sensors, or sort of the the cheaper sensors, I should say, which have sort of come around with the evolution of mobile technology.
I would call them the affordable ones, not cheap. You cut
Affordable
your
ones,
cloth
yes.
according to the money you've got available.
Okay, fair comment. They're the more affordable sensors. So historically, most of the high criticality assets would have sensors on them, but these sensors would cost in the thousands, if not tens of thousands. The smaller sensors cost considerably less than that, or a bit less than that, making them more affordable for the medium criticality to low criticality assets.
Okay.
And if I can add, in addition to affordable, I think, especially from corrosion monitoring area, it's mainly the connectivity. Because if you go back, I don't know, 5 years, it was not common to see the sensors that can be connected wirelessly. Nowadays, it's a norm. However, even nowadays, if you compare differences between LoRaWAN connections and wireless HART connections and how it impacts, for example, on the battery life of the sensors, then you realize that this technology constantly develop. It's not just the batteries getting better, but also the connections networks are developing as well, and that allows you to choose different options.
Okay, and we'll just stop in with the sensor theme for a minute because you've sort of moved on to a little bit. Is there for the the thickness sensors, is there a sort of practical real world temperature limit for that?
Yes. So obviously you can find sensors that go from -40 up to +600. So this is really the extreme. But then you need to be very specific for your environment, because commonly high temperature sensors have a different design. They also need to be installed differently. High temperature sensors needs to be welded compared to low temperatures that could be just clamped or be magnetic. So there are a lot of things you need to consider, and it's not like one sensor fits for all. You need to understand thicknesses, you need to understand the material, but more importantly, understand the temperature, and then you can select the sensor based on that. But commonly, as I said, the range is very big, from -40 up to 600 degrees. Not everyone is requiring this temperature, so commonly we would see it ambient temperature to up to 200, 250. This is most common, but as I said, you can find sensors which goes beyond those range.
That was Shirley's question, sorry, it wasn't mine. And also, from my question as well, the same sensors about corrosion monitoring, a lot of the corrosion mechanisms are cracking, stress corrosion, fatigue, etc. Are there any sensors that can even measure that, or that I would trust?
Good question. And this is where maybe expertise comes in place, that you need to merge understanding of the damage mechanism with understanding of the sensor technology and select the best. So it's not, there are some sensors which are not off the shelf, but what I just described today, it was pure corrosion, so it's only looking for the loss of material because it's a UT based, which also means that through this, you don't know whether corrosion grows horizontally or whether it grows vertically. So that's also a very important point that you need to understand. But they will not apply for other damage mechanisms. However, talking about the creep and creep fatigue, there are totally different construction, but we have know-how. In fact, this is in-house know-how using DPD principles, which applies, and we can monitor the stress, fatigue, and corrosion cracking from that.
Okay, let's just move on. It's complex, and I don't think most of the attendees will be into that.
What I wanted to say is that there are options. We just need to go deep into that.
Okay. Rodney Gilmore, what sort of vibration can the asset insight sensor be used for? We've vibrating equipment that operates at 6G, but we're looking for something that can measure when that goes outside of that range. So these, they're not small vibrations.
No, they're not. They're quite big. So I don't know the top limit off the top of my head, but the sensors are configurable to capture a broad range, going from the really, really low forces to quite relatively high ones. I don't have a number that I can give you off the top of my head, unfortunately, but we can explore that user case in a bit more depth if you'd like.
I presume it's on the ABB spec sheets, but I don't know. But
it is, yes.
Yeah. On the same sort of topic from Barry Jenkins, what's the real world range of this ability smart centers, say inside a typical plant room with lots of other monitoring, comms, and electrical noise? Do we need lots of network mesh system to use it, LoRaWIN, BLE, or is this another comms protocol and certified? Is it certified as encrypted from a security perspective? So a million questions in one.
It is. So the sensors communicate via wireless HART using an encryption code, which is it's a very long code, effectively. The sensors can mesh off each other, so they're within range of each other. They can use each other to piggyback the signals, but an individual sensor by itself has got a range of up to 100 meters. But again, that's impacted depending on what sensors or what equipment is around it.
Okay. Keniswami Luai, I apologize for the pronunciation. How would you integrate APM and condition monitoring with risk-based decision making to ensure reliability, maintainability, and cost optimization, particularly in regulated industries?
So I think this will apply for both static and rotating equipment, but the answer that we have within TUV is that you need to use whether it be your RBI or IMechEs or any sort of risk assessment that you carry out on an asset to determine where the asset is going to fail, how it's going to fail, and then what deterioration mechanisms or what failure mechanisms you're looking for that sensor to pick up.
Please.
Sorry, and ultimately, once you've decided all of that, you develop your procedures around getting that data and sort of making an informed decision out of that data.
Okay. I think we'll get the questions in just in time. I'll leave that question for last. How do you monitor corrosion by hydrogen sulfide? It can develop really quickly. Do you have any experience with it, Sergey?
Good question. Not from top of my head. I mean, we are familiar with, or I'm personally familiar more with HTHA, which is also very fast corrosion development or crack development in this case, but it's at a much more micro level. So that's why at the moment sensors are not able to pick it up with a sulfur corrosion. To be honest, I need to check with my expert. Not able to answer.
It's definitely an oil question, isn't it? It's an oil refinery question, either from Middle East or America, I think, or perhaps even Russia.
But I'm pretty sure we'll be able to find an answer. So I just need to maybe engage a couple of experts from this area.
And now, Alfred, I have got your email address as part of one of the responders. So some of these questions that are answered, maybe Sergey can follow them up afterwards with an email to you, assuming that you're okay for me to use your individual email address for that. Is there an international standard for this stuff? I mean, there is the ISO 55000 series for asset management. They don't really cover this stuff, though, do they? So is it the Wild West that each company is developing their own way?
Within condition monitoring, there is a recognized ISO standard. I think it's 108 off the top of my head.
No, not condition monitoring. I mean, the smart stuff and integration with software tools and analytics. It's just developing really quick, isn't it? Yeah. No, I get the CM standard. That's fine.
Yeah. So in terms of communication protocols, there are standards out there. Whether they are specifically designed for condition monitoring or not, I wouldn't have thought they would be, but they are designed to sort of keep your data encrypted or hidden or less available to open interception.
And certainly I work in the high hazard industries, and we wouldn't touch off premises storage in clouds with a barge pole on high hazard plants because of there is no such thing as full security. All you can do is make it as good as you can. So we wouldn't trust it. But encryption is certainly possible and used. So I think we need more information about that, certainly, because I certainly don't get it. But then I'm only a mechanical engineer, so what do I know? Is it, the best question for last from Alfred again. Will AI take over condition monitoring?
It's a good question.
It
I
is.
wish someone could have a good answer.
I think, to be honest, I think the sort of thing that I keep deferring to half the time is there always needs to be a human in the loop taking the decision around what you do with the data or what the information of the AI is providing you. So I think I do see AI enhancing the decision-making capability, but it's ultimately someone like yourself, Alfred, or anyone else who's participating in this call that has to make that decision around whether to take that asset offline or replace a component or even listen to the AI to begin with.
I think it's
I mean,
the moment
I actually put a comment in when he asked the question. From my perspective, AI is just another expert system trained on data. That's it. It's a new name for the same thing. For it to be trusted, it must have access to a huge data set of real world machinery and results, and to be proven to give good advice, because we know AI can give phantom answers. So yeah, I think it's got possibilities, but I ain't trusting it anytime soon. Anyway, sorry, Sergey, I interrupted you.
I just wanted to say that indeed, I think in the nearest future, we would still see it as an advisory tool rather than kind of management tool. But I just want to state that the speed of the development of artificial intelligence is exponential. So what's not possible, or maybe not foreseeable today, the day after tomorrow, it will be common. So from that side, I'm much more optimistic that we will see more and more enhancement and support from the artificial intelligence. But for the nearest future, I fully agree with you guys that humans will drive the process. We will just need extra support and making certain tasks much quicker. For example, instead of going through the data, which takes days, it could be interpreted within a couple of minutes and then point us humans to the areas where we really need to focus and pay our attention.
Listen, I think we're going to have to start to draw this to a close. I think you've had time to get the details if you want to follow up with an email. But I'll also just share a couple of IMechE slides. The webinar recording will appear on this page. You can look it up on, and there's a QR code there as well. There's lots of webinars already. We've got a couple of ones in the very near future coming up. Introduction to valves in the water industry. A lot of people are registered for it as well, which sort of surprised me. I think we're going to try and follow up with some other ones as well in process industries, because you'd think it's pretty basic, but actually a lot of people haven't got the information. There's a lot of choice. And there's an interesting one as well. And I'm chairing again. Recovering of a process plant, refinery after a major fire. A lot of interesting snippets of information there. So look them up. You'll find them on YouTube or on near you or wherever. There is a QR code if you want to give us feedback. I've checked it. It goes to the right place. There are also some other forms and surveys going on. If you ever want to get involved, either just to request that we run an event that you don't know something about, please, make the suggestion. A lot of volunteers try and do this stuff. We're just trying to provide a service that we might think help people. Likewise, if you want to get involved, feel free to do that as well. So I'll just leave that up while I say again, thank you very much to Sharif and Sergey. Excellent presentations, excellent questions and answers to the audience. We peaked at around about 90 people, and there's still 70 odd people on. I'm just trying to think on the chat, is there anything else? No, just people saying thank you, I think. So I'll stop the recording now. It'll appear on YouTube in a week or two, hopefully. And thanks again to everybody. And if the speakers can just stop on for 2 minutes, then we'll be right, I think.
Thank you.
Thanks, everyone.